Hello again, everyone. I'm Natasha Reeves, and we're going to go through the Adaptive Sweep Surface Feature Essentials. And we're going to start off by mentioning the environment. So the objectives of the webcast are to learn how to create a swept surface that uses the implicit profile and its constraints along a guide curve. We're going to learn how to add and control the section dimensions of an adaptive sweep feature and learn more about the optional elements of the adaptive sweep feature. So with the advanced surface design course, CATIA, that we provide, we have the specific chapter that gets into the tool adaptive sweep, and we're going to gain an understanding now about the creation process and the elements of this feature in order to create this surface geometry. So first off, CATIA has several different workbenches that allow you to create surface geometry. The primary workbench is the generative shape design workbench. And so with the generative shape design workbench, or GSD workbench, we have access to many surface creation options, but specifically we're going to cover the adaptive surface tool. So this illustration here shows the shortcut for the generative shape design workbench and how we can access this workbench. You can see you can go through the start menu, and then from here there is a shape option, and then you can get into various different workbenches. For us, we're going to get into the generative shape design workbench, and within this environment we can create and edit and analyze geometry, wireframe geometry, and surface geometry, again, through this single workbench. So if you are in the generative shape design environment and you go to the surfaces toolbar, an illustration of which is shown above here, you can go into the area where the sweeps sub toolbar is located, and you'll have both the sweep tool and the adaptive sweep tool, which is the what we're going to concentrate on in the class. But it's definitely worth mentioning that there are several surface creation options. We're talking sweeps specifically. And with surface sweeps, you assign a profile and a guide curve, and your profile is swept along the specified guide curve. Now with the sweep tool, you can see from the description there, you're going to generate your output whereby the profile follows the guide curve. And notice there that the profile can be something that you have pre-created and selected, or you can create the profile during the process of defining the sweep or on the fly. And then with the adaptive sweep, you get to sweep your profile along your guide curve, and the tool itself allows parameters to be evolved along the progression of the sweep. Do notice that you do need a particular license for that particular tool to show up. So if you don't see it, you might have to access the HD2 license. Now, this illustration here shows on the left there the sweep tool from the sweep sub toolbar from the surfaces toolbar that I showed on the previous slide. And when you do go into the sweep environment, there is a dedicated definition dialog box. And with the explicit type, you do have a few options that you can assign to help to define the swept surface. You can see with surface, or with reference surface, with two guide curves, and with pulling direction and descriptions of each there. Now, the adaptive sweep, again, is a surface that can adapt to changing dimensions of the parent profile along your defined path. You do have some key points that need to be specified when we're talking about defining the adaptive sweep. First and foremost, the sketch of the adaptive sweep has to be constrained. You have to have a constrained sketch. A constraint is created between the guide curves and the sketch origin, so that the sketch origin is always placed on the guide curve throughout the length of the sweep. The surface itself is computed along the guide curve with respect to the sketch constraints and dimensions. That's both geometric and dimensional constraints. To make the dimensions of the sketch vary, you do have to have these values created in the sketch so that they can be presented at the point where you define individual dimensions along the guide curve. From there, you can ensure relative positioning of the sections with the reference elements through your constraints. I'll give you some tips on certain constraints that can allow for appropriate interaction between the profiles and the curve, the guide curve. And you can specify different dimensions for the sketch at every what's called user section. So we'll go into that a little bit here. Let me mention some summary of what we just stated. The adaptive sweep itself is, as you can tell from these bullets, different from what would be the simple sweep with the explicit option, basically because the adaptive sweep surface inherits the sketch constraints along the surface that's created. The adaptive sweep allows you to create intermediate sections, which are known as user sections, on the fly along the guide curve. The adaptive sweep allows you to modify any intermediate sections individually, and the adaptive sweep ensures that the profile is normal to the guide curve at the time of creation. So let me go to this next image right here that shows the general steps that one would use to create an adaptive sweep. So that icon that you see is the icon from the sweep sub toolbar for adaptive sweep that you would press to initiate the creation process. This is the dialog box that pops up after clicking the icon. So going back to the summary real quick, you can see that you will need a curve that will be your guide curve. You can either select or create, like I said before, the profile that's going to follow that curve. And then you have the ability to define at different point locations across the guide curve unique sections using that user section tool. Again, this is the interface that pops up when you're in the process of creating an adaptive sweep feature. And I'll show a few of them a little bit later. Before I go into any further detail, I want to stop right here and go back to a previous image right here showing the sweep tool. And then, of course, you can see the icon once again for the adaptive sweep. And I just want to bring up a point here. In a couple of interfaces, I do have both a sweep created with the adaptive sweep tool, and in this other window, I have another sweep that was created with the sweep tool. So I'm going to double click on the sweep tool since I'm here. And this is the swept surface definition dialog box. What was done here to create this structure, I'll just delete that real quick, is I took the closed profile that you see here as the shape to follow the guide curve. And this open chain element that you see here is the guide curve. So by going into, and here's the surfaces toolbar here, by going into, here's the sweeps flyout, the sweep tool, you can see the dedicated box that we just talked about. Underneath your profile types, one of your tools is explicit. And with explicit being selected, you can specify a sketch profile to follow a guide curve. And let's just hit this preview button right here. This is what we saw when we first came into the environment. So let me just kind of, well, let me finish that. We'll go back here and pick on the profile and the guide once again and hit OK this time. And then we'll get our surface. This is what we were looking at prior to me removing what we had and then creating it again. And when you look at this output, it does look very similar to what we have in this other window that was generated with the adaptive sweep. And so let me double click on this feature. This is the adaptive sweep definition dialog box. And essentially, I started off with the same start geometry. Let me just get rid of this real quick. I had a dedicated profile. Again, I started with the same geometry, and I had a dedicated single guide curve. I even called it guide, as you can see right there. So the profile that looks there, I called it profile, and the guide curve here, those are the references for our adaptive sweep. So we'll go ahead and pick the guide curve here. And for the profile, the sketch profile is its name. And then we'll just hit preview to leave the box up. And you can see the output here, a profile following a guide curve. And we'll just say okay at this point. And based on what we just showed, there's a lot of similarity here between the sweep tool using the explicit profile and the adaptive sweep. Now, the adaptive sweep does allow you to sweep along the length of a guide curve in order to generate the surface geometry, but it also, as we'll go back over to that window with it in it, allows you to define unique dimensional values for the profile at different positions along the length of the guide curve. And so what I'm going to do here, since I brought up all these windows, is to go into yet another window. Well, let's see here, that we were in before. And just let me, since I'm here and I don't think the other file, I'll just create what I might need here. I'm going to, just to differentiate the environment, I'm going to set up another geometrical set here and just create it with a nice name. It's active. We'll come over and create a couple of points here, and I don't need to hide the adaptive sweep, so I'll just go ahead and select that guide. We'll just put in a point here at a specific location, and you can see the 0.3 element or feature right there. All right, if it helps, we can hide the sweep real quick. All right, and then we've got the ability to put in points plural. So we'll put in yet another point here and we'll just nicely put in a nice position. Now, in the traditional sweep here, we do have some options here, but none of them allows me to come in to any of those points that I just put in and assign different dimensional values to the profile at those points. But if I were, and I'll just stay here so I don't swing back to the other window, I'll just take out, leave out that sweep in view, and we'll create an adaptive sweep here. Let's just go into the flyout and do that. Use the same guide curve and profile. And of course, when you look at the adaptive sweep definition environment, we've got a couple of different tabs within the environment. So sections tab, more specifically, is the active tab at the moment. So what we can do here is define different user sections. Before I go too much further though, if you remember the profile there, profile, we'll go inside of the part body, which is where I left it. And I'll double click on it. And you can see the shape here as it's defined. And if I had some dimensions there that I wanted to set up some variances in the shape, I could go about making that happen and making that happen at different points along the curve. Now, I'm going to leave this here as you see it without a lot of constraints defining the shape. This will give me an opportunity to go into one of the other sessions that I have up here, and we'll click on the profile here, and there we go. We'll this time come in and define that shape with some dimensions. So I have this already in one of these windows. Let me go back here and check. So what we'll do here is define a couple of values that will allow us to make some adjustments to the contour. So let's do that here as we were going to before. So let me just accept. This is blocking. All right. Some of my controls there being blocked by that toolbar. All right. So This is looking for the one with the points in it now. Okay, here we go. All right, so here's the one that we were looking at earlier that we've got the geometry that I need to set up the different contours. So let's go back into the adaptive suite, which is here. Okay, so we're going to set up at this location here a contour. We'll push this up a little bit so we can see, and I hope you can see without all that red blocking your way. The other point 4 that we created a little earlier along that curve, and we can even pick this endpoint here along the curve to set up yet another user section. These are internal profiles at point locations across the guide curve, and you can see defaultly named there some additional sections. The first section, of course, is the profile that we initially selected to follow the curve. You always start with at least that profile. But if you would like additional ones while you're on the sections tab, again, you have to have your points that you're going to place these on. So you saw our third point that I created along that curve, a little bit high up on that end right there where you see it. And then there was the other point that you saw me create there, and then the end point there at the bottom of the curve. We'll just start there. And right here on the parameters tab, you'll see the listing of all of those sections. So you remember back over on the sections tab, our first profile, there's the second one, the third one, and the last one there at the end point. And so let's click over here on the parameters tab where we can see the drop down showing our different sections. So there's our first section, our second section, our third section, and our fourth section. Now, what we've got here currently, and I'm glad this happened, is you saw it, our profile doesn't have any dimensional aspects associated to it. So we're going to okay this adaptive sweep at the moment, and then edit our profile here to contain some values. So button's kind of hiding here, so I'm gonna minimize this slightly. And then over here, push out the constraints toolbar so we can go to create dimension, and we'll create a dimension from these two, well, prematurely picked, so I'll move this guy here. Let me just get rid of that for now. And from here to here, make sure I grab the endpoints. Hold on for a second. It's Monday, but that's fine. I'm gonna just hide this to make it easier on me. So here we go. No distraction. Should be able to nicely get a value. And let's push this pretty over here. And then just for kicks, we'll throw in another value here. All right, and I'll do a width here, which I get rid of that one there so that we can fully constrain with no distraction. So in addition to some of the conditions that you see, tangent and collinear there, we do have some dimensional values there sizing out our shape. Now we'll go back over here, coming out, hide again, of the workbench. And you know what? Now that I've got this, let's make this bigger. And now bring back in our adaptive sweep. All right, I'm sorry, I said adaptive sweep. All right, and so now that we've got all our nice parameters, you can see for yourself there what did not exist did not show, and what now exists does show in our list of parameters. All right, so I'm sure that makes sense to everyone. You can't edit what doesn't actually exist. So just to push in a couple of different edits, we don't want to be too dramatic here. We'll go to the current 67 value here for the second user section, and I can verify that it's the second one here momentarily. We'll just kind of swelf this a little bit, make it a little bit smaller, as you can see there. See the second section. And then we'll come over here to the third profile here. And you can see the list of parameters based on how they were defined in the first profile. Make this a little bit smaller than what we had in the second profile. And then we'll go down to the third profile here. I'll tilt it slightly. And then we'll just go to the 67 here to get this moving. And we'll say 30. That's the first thing hit my mind. And then we can do a nice little preview here. And you can see that the dynamics of the adaptive sweep adjust at those different location points where we define user sections. And the values were driven independently for each one of those. Now, I didn't choose all of them, but you saw that what was there could be edited or kept common between the shapes if that's what I need to do to get the resulting surface created the way we like. Let's hit OK on that. We'll go back to the images of the information once again, just to make sure that we put in words all of the steps that we went through to make what we saw happen. So first and foremost, we did click on the adaptive sweep tool. And from there, we launched the adaptive sweep definition box. I could have pre-selected the guide curve and then the sketch profile, but I would have had to do it in that order if you notice here because of how the fields are defined in the definition box. You can choose the tool and select after the fact if you need to. But if you are going to pick your geometry before selecting the icon, you do have to choose them in a particular order. You can clear later, but it just makes it easier if you do it in the order that they're populated in the box. You noticed a few times, by the way, you noticed with the adaptive sweeps that I was creating that the guide curve also populated in the same spine collector. I'll speak more on that here momentarily. Of course, you can see a reference surface area. I'll speak on that momentarily too. And of course, the sketch area. So between the guide curve and the sketch collectors, you saw different variations. Now, the sections tab itself is where you initially see the profile that is specified for your adaptive sweep. And if you are going to define additional, again, what's called user sections, you'll see them named here as well on the sections tab. You will have to have points very similar to what you see on the specified guide curve in this illustration here assigned in order for you to have user sections at those points. You'll need to make sure that you do that. Now you can do it before you create the adaptive sweep, but you do have to do it, is the point. So from here, I want to speak on some aspects of that guide curve. So initially, as you saw from the previous box, let me go back here for a moment. The spine collector is initially identified with the same selected guide curve reference. And you can change that. You can select the spine if you want it to be different from the guide curve. We can illustrate that a little bit later. If you notice, or I'll go back so that you can notice the reference surface field, that is optional. And if you do have a surface that your guide curve lies on, CATIA is going to use that to define an axis system in which the swept surface is created. So it helps because you have the H and V axes for constraining purposes. A lot of times you do this so that you have tangency to the reference surface of choice. You can create a reference surface on the fly if you wanted to. You can right click in that field there and go through the process of defining a reference surface. You can pick even one of the planes, like the XY plane from the model as a reference if you get that to do what you need. If you have a mean plane definition, for example, that does what you need. Otherwise, what I have in this other window here, I do have a profile, sketch 4, We can call it profile, but it's nothing fancy. And there I go again, the button. I'm gonna push this out here so we don't have to keep doing that. All right. And I do have a couple other curves here. Let me go back into that sketch though, so that you can see that there are some constraints, obviously. But let's look in here, right? There's a coincident constraint here relative to another curve. This curve right here is actually an extracted boundary from a surface that I hid, as a matter of fact, this revolute here that you see now. I'll go back and hide it because it's visually distracting, but that boundary curve right there was extracted from one of the boundaries of another surface feature. And there's an actual connection there between this sketch and that surface and boundary. There's another coincident constraint down here at the bottom or end of the section to yet another curve. That's a combined curve element right there. And so when we come out of this sketcher environment, and now that you see the sketch in its relationship to these two other curves, if I were to go this time to adaptive sweep and then select as my guide curve that extract curve, and notice it's populated as the spine reference as well. The profile here will pick out right there on the screen. And then based on the coincident connection here of the endpoint of our sketch feature to the other curve here that's tinted green, we'll say okay here, or preview in case we want to see that box again. We'll come out a little bit. You can see the resulting adaptive sweep here as it is following the guide curve. It is based on that constraint condition there, also following the other boundary. So it is possible there, based on shape, for example, to have some varied contour there. And that's not necessarily what you can do in the same sense with the explicit sweep. The fact that we do also have those other constraints here in the profile. If we chose to define at different point locations across the guide curve other parameters than the ones that are currently assigned to the first profile, then you see even further variance of the shape as it's projected. And that is unique to the adaptive sweep. From here, this gives you an image of the sketch creation environment when you are defining your points on the fly. You can do that, or you can do what I did and create your points as independent features so that they can then be selected while you're defining the sections at those points. And then of course you can go in if you need to. It was the parameters tab to each section individually and edit any parameters. So you do have some other, what I call bells and whistles or elements along the way that can give you even more control over the shape, but we'll speak on those here in a moment. This image right here does show pretty much what I showed earlier. The contour varied at different positions with different constraints individually assigned in each user section to give you your output. In this sense here, the reference surface is the XY plane that was used as a way to control the internal shape. So it's nice and tangent to the contours along the way. Before we go there, I'm going to go back here to a couple of these images here so that we can see some other aspects or reinform or reiterate, I should say, some more of those aspects. If you allow me to, I'm going to double click on the adaptive sweep here. And it is this icon here. I kept saying you can make the sketch internally if you had to. Of course, if the sketch is already made, that tool itself can also be used to edit the contour. So I know I went out earlier and went to the profile specifically from the environment, but that's because I wanted you to know where it came from and how it related to the shape. That's the same contour that we selected to create the shape itself. And here, hit again. Let me push this out so we can just click there. And also, let's click on the parameters tab there. Don't forget that you have a listing of sections. Don't assume that you're on the section that you want to edit, but you can see the section that you do want to edit not only is named in that current sections list, but also shows a highlight while it's active on the screen. And we'll go to 2, for example, and show it, just to be a little different. Go to 3 to show it. And then, of course, the first one that was selected initially, that's populated in the same sketch collector. All right. And so you can edit these values on the screen. I know I didn't do it, but we are talking about what you can do. So this time I will. And you can see that whether you do it in the dedicated definition box or on the screen, the value gets edited. All right. You do have this deviation field and angular correction that can give you even more control over the contours if you need to. You might want to start with a low deviation to help in the progression of the sweep without a lot of bumps. If you ever notice your shape has a lot of bumps or lumps to it, you might be able to come into this deviation field and adjust the values. Usually you can go a little lower and it helps. If you get to a point where the value is not something that can be regenerated, then you don't get output. So if you tend to get to that point, kind of playing with that field, in some cases, the dialog box that pops up when there's an error will give you a range, suggest a range value. But you can come in and you can adjust this field and see if it helps in any way. And those are pretty low numbers there. You can go high. And although I'm hitting enter key, you can hit preview and you can still get any error boxes that might come up that give you those tips that I mentioned. The relimitation tab, don't want to forget it. If you go to the relimitation tab, it will have those 2 checkbox options there, relimited on start section and relimited on end section. That relimitation tab allows you to create what's called multi-section sweep surfaces, where you can adjust the contour while still staying with your guide curve. You can specify different relimitations at either the start or the end. So you can choose to limit the sweep only at the start or only at the end or both or neither. All right, so checked is, defaultly on, but you can clear that if you wanted to, or if it gave you what you wanted, more importantly. The swept surface itself can be closed if your guide, curve, and spine are closed. Mine is open here, so it's going to give me some problems. But if you had a closed guide curve, that might be something that you want to do, close or cap off the end without having to create an extra fill feature. You can clear both options, and what you're told is if the swept surface is swept along the spline, it's going to be relimited based off of extremities in the spline or by the first guide extremities. So the way you constrain your shape is going to have some effect on that as well. As far as some extra tips go, I was speaking on gaps and bumps a little bit earlier. If you can avoid unnecessary surface qualities like gaps between your surfaces by selecting boundaries that are next to the surface, that's a good practice to get into. It's not a need for what I did here, but it is what I did because of experience, creating an extract curve from that surface there that I just double clicked on, and using the extract, which is a parent element, obviously. The surface itself is a parent element to the extract, but the extract is independent in the sense of selection. It's its own feature there in the tree. And sometimes if you run into issues and you've already created some type of extracted boundary, those can be isolated. You can come in to an extract or boundary independent feature, and you can choose to isolate it as an independent structure. That will detach it from the parent surface, and that might be enough to avoid gaps in the surface, right? And that's a better quality in most cases. That's something to think about, because remember, that's going to separate it from its parent source. But if that's what it takes to change the quality, to what you need, then it's an option. We're only talking about options here. And so that's everything that I had information-wise for the sweep surface, the adaptive sweep surface. You do have the information that I added in there about the explicit sweep from that standpoint. The adaptive sweep is in some case more flexible because of that capability of generating the different shapes based on selected and specified points and then edited constraints along those points. So as a summary to everything that I mentioned about how CATIA self calculates the adaptive sweep, I'm gonna go back to that image that showed that so that we reinforce what I showed through the actual demonstrations.